Let's look at OpenStax College Physics, Chapter 22, Problem 1. What is the direction of the magnetic force on a positive charge that moves as shown in each of these 6 cases in the figure? So we're going to take one at a time. And here we have the first drawing. We have a magnetic field coming out and the velocity is down. And we know that the magnetic force has a value of charge times the cross product between the velocity and the magnetic field. So the magnitude of the force then is just the charge, magnitude of the velocity, magnitude of the magnetic field times sine of the angle between V and B. And if the angle is 0 or if the angle is 180, sine of 0 and 180 is 0, so there is no force. So that means that if the velocity and the magnetic field are parallel or anti-parallel, there won't be any force. So we will see this in different examples here. So let's follow this video. So here we have the velocity is going straight down. We put the hand along the velocity in the same direction as the velocity, and then magnetic field is out, so we have to turn our hand so that the fingers can come out of the picture here. Velocity is still down, fingers are still pointing down, magnetic field is out, and the force is going to be in the direction of the thumb. Let me draw that on here. So I have the force then is going to be in this direction, and that's of course the case here as well. And we are dealing with positive charges, so we have the magnetic force in the direction of the thumb. Had it been a negative charge, then the magnetic force would have been in the opposite direction because we would have had a negative sign here for the charge. All right, let's look at the second one. So here we have a magnetic field to the right and the velocity is straight up. So we will place our hand in the direction of the velocity. So our hand has to go up like this. And then we have to bend the fingers in the direction of the magnetic field. But we can't bend them like that. So we have to rotate the hand, still keeping it up, so the fingers still go up, so that the magnetic field can be in the direction of the bent fingers. And then the force will be in the direction of the outstretched thumb, so that will be into the board. So we will have a magnetic force into the board here, and that's of course the case here as well. So that's the magnetic direction of the magnetic force. Now the next example has velocity to the right and the magnetic field is into the board. It says so right here. So we place our hand in the direction of the velocity, so the fingers go along the velocity, and then we bend our fingers into the direction of the board. So we bend them in like that, and the outstretched thumb will give the direction of the force. So let's draw the force on here. Force was that way. So that is the direction for the force by the right hand rule. Next example, now we have the velocity going to the left, so we have to place our hand with the fingers going to the left like that, and then we have to bend our fingers in the direction of magnetic field, but we have to bend our fingers 180 degrees. Remember that if 180 degrees is the angle, sine of 180 is 0 and there is no force. So the force in this example is 0. There is no force. For the next example, we now have the velocity going into this board and the magnetic field is up. So we have to place our hand in the direction of the velocity. So that's into this board. And then we have to bend our fingers in the direction of the magnetic field. So we can't bend them that way, we'll break them. So we have to rotate the hand so it still goes into this board, and then bend the fingers up along the magnetic field. The outstretched thumb will be the direction of the magnetic force. So the force goes this way. Last example, we have a velocity coming out of this board and a magnetic field to the left. So we'll place our hand in the direction of the velocity, so the hand has to come out of that board, and we have to now bend our fingers in the direction of the magnetic field. Well, we can't bend them that way, so we have to rotate our hand, still coming out of the board, and now we bend our fingers in the direction of the magnetic field. Then the outstretched thumb will be the direction of the magnetic force. So these are a whole bunch of examples of the right hand rule. I would like to thank my son for drawing these things on the board and for recording the videos. And then I would also like to thank my husband for taking the sound out of these videos that I embedded here.